So, dimensional analysis, knowing how to take a measurement of something and convert it into something else. Handy when you're working on something, also handy if you're ever running into some sort of a standardized test, whether that's a college entrance exam, whether it's an ASVAB test, going into the military, all of those different things. These tend to pop up now and then. And so, for instance, and you might know this off the top of your head even, so I wouldn't, be shocked if you did. Determine how many inches are in 4 yards. So when we're going from yards into inches, there are ways we could do this in one step. It's true. But there's also ways, if we're not sure about some of the measurements in between, yards to feet, feet to inches, things like that, that we can kind of work our way through. So, the first thing we normally do is go from the largest measurement down to the next smallest one. We normally don't take the huge leap. So with yards, we normally go to feet next. Since there's 3 feet in a yard, which is where I'll start before I get to here, what you're going to want to do in dimensional analysis is make sure that the previous measurement always gets canceled. So when you're going from yards to feet, you put the yards measurement in the bottom part, or if you're looking at these as fractions, in the denominator. And that way, as you start to work along, and you see it down here a little further. So currently here, the yards would go away. We'd be measuring in feet. Now that's not what I want, because I want inches. And so I keep going. And so I'm like, okay, so when I'm into feet, well, now I want to get from feet into inches, because that's the final place I want to get. So there's 12 inches in a foot. So now I canceled out the yards. Now by putting 1 foot is 12 inches, but putting the foot down below, the feet cancel. We can't cancel side to side. We can only cancel top to bottom, which is why we put it there. And when all those things go away, the only thing that's left is the 4, the 3, and the 12 to multiply together with the one measurement that we want, the inches. So 4 yards is 144 inches. Now, if you knew already that a yard's 36 inches, you could go do it in one step and be done. There's not a surefire way, depending on the background that you have. So let's play with a few of these. Maybe we can find some ways to go speedy. I don't even know. So what's the highway speed limit of 65 miles per hour? So 65 miles per hour in feet per second. Oh boy. So let's see here. What do we want to do? Well, first I would say we want to get rid of miles. So we want to figure out something that's going to let us get rid of 1 mile here. So let's see. Miles, I'm going to go use my page 19 here over in the practice kind of as my guide. So distances, okay, there's a mile. A mile is 5,280 feet. So first job. So what this first step allows me to do, over on page, yeah, I was going to say, let me kind of do one of these. Let's do this. So I'm kind of going back and forth here. We're working on the notes, but when I need any of the factors, I'm stealing it from page 19 in the practice. It's the one thing I didn't like about this. In retrospect, I'd have made like an extra little card of this. But I didn't. Gotta remember these things. So let's do this. Ooh, that's not bad. Okay. So far, I'm down to feet per hour. You're like, Hardy, that's not what we want. We want feet per second. So I'm like, okay, well, let's see here. Let's wipe out hours next. So here, and again, we're on page 13 of the notes. We're going split screen here. So notes, page 13, and then we're getting the chart off of the practice on 19, or you can kind of follow along with mine for the moment if you want to do that. I'll try and keep it on the screen. What's that? Okay, let's take a peek here. If we need to get... So next job looks like we want to get rid of hours because we want to start working into seconds. So 1 hour, what measurement? Let's see here.
60 minutes.
Perfect. And you're like, well, wait a minute. The last time you put miles in the bottom, why are we putting hours up there? Because again, we've got to make sure if we want hours to go away, they're on opposite sides. One on the top and one on the bottom. We're getting close. We're into feet per minute. We need feet per second. What?
60 seconds in 1 minute.
Okay. So 1 minute is 60 seconds. We can get rid of the minutes. Now we just got a whole lot of multiplying to do. So let's see here. Across the top, we got 65. We got 5,280. Holy moly. 343,200 feet. We're going to be reducing this momentarily. 1 and 1, and then 60 times 60 is 3,600 seconds. So we're now to feet per second, but to get an honest feet per second, we actually have to divide this because we want to know how far we're going every second. And if you get a decimal, not a bad thing, we're just going to go to 1 decimal point. But make sure your labels stay. 95.3 feet per second. That's pretty quick. Pretty quick. I don't think I could go that fast. Then again, I can't run 65 miles an hour either. So that's basically the trick that we're running with these. It's just getting those conversion set. So let's see. How many kilograms per cubic meter? Ooh, are there in 3 grams per cubic centimeter? Okay, so 3 grams per 1 cubic centimeter. Now this is not one I know off the top of my head, so I'm going to have to use the factors here too. We're trying to figure out kilograms per meter. So let's see here. Let's say if we wanted to get rid of grams, because we're wanting to get to kilograms. So let's look around here. Ooh, now this one's going to be different. I got ahead of myself. If I'm wanting to get to kilograms and grams, here's the comparison I've got. So let me change this for a sec. 1,000 grams is 1 kilogram. So that would help us get rid of grams and 2 kilograms, so that's good. Centimeters looks to be what we're dealing with next here. So let's see here. Ooh, we're going to have a few conversions to deal with here, aren't we? And I'm going to have something to help out with because for some reason I don't have that on here. So let's do this. So I do know that 100 centimeters is 1 meter. So I might not be able to get rid of the cube yet. So let's just kind of keep rolling here. I don't have to worry about the cubic quite yet. But now here's the thing. This one is tricky. I'm going to give this one a star. Because here, this 3, okay, means I've got to do this 3 times. So if there's 100 centimeters in a meter, I'm actually, to get rid of that 3, this is an oddball. Why I chose to put this one in here, I don't know. Let me try and explain why we got to do this way. Even though I could have done it cubically, I think that would have been harder. So if you've got a label on one of these, it's got a 2, it's got a 3, it means you've got to wipe it out that many times. So for instance, a sticky note for this. So if I have cubic centimeters, it means I have centimeters times itself 3 times. So to make this go away, I need 3 regular centimeters to make the cube one go away. So if I take all 3 of these, that will wipe out the 1 and take care of that. That one is a strange one. We won't see that very often. But it did get us to where we were trying to go, because now I see kilograms on the top, if I can get this off. And on the bottom, check it out, meters times meters times meters is,
Meters squared.
there it is, our cubic meters that we need. So, let me move this off for a sec. Multiply in time. Big numbers incoming. 3 times, I can do the 1. Make sure we get all those in there. Holy moly. $3 million kilograms. That's a lot. Bless you. And then the 1,000 is my only number down in the denominator. So we're going to take our 3 million and divide by 1,000. We get 3,000 kilograms per cubic meter, which is what dimensional analysis is. We want to know for each one how they work. Again, that one was weird. It's good that we got that on there in case something like that would come up again, but hopefully it doesn't. Because if it does, not the most fun. I think we're going to get back to some regularity here on the next one. So let me get this all back onto the same screen here as we turn over to 14 in the notes here. And just to make note again, just because I've got these like charts that are bigger, it doesn't mean you got to use every single square every time. We only maybe use a couple some of these. So let's see, 261 grams to kilograms. Now here's another little change. Here, I don't have something else to put down here in the denominator. I mean, if I want to put something, because I want the box to have something, I can put a 1. But I want to turn it into kilograms. So if that's true, if I want to find kilograms and grams, okay. So 1 kilogram is 1,000 grams. And then the grams go away, and all of a sudden, like, hey, kilograms is what I got left. That's what I'm supposed to get. That's all I need this time. Okay. So let's see here. 261 divided by 1,000. Ooh, I got a decimal. That's okay. Decimals are A-okay with these. Just make sure to keep your label. And again, the kilograms is on top.
It's the same numbers, just with the decimal in the front.
That's right. Just divide it by 1,000 and move that decimal point over. Absolutely. So again, not too bad. Okay, I got one more I want to do before I freeze frame one and kind of have you try one on your own here. Let's try number 2. Days. Oh, 3 days to seconds. Holy moly. All right. So 3 days. All right. So here, and again, if you can think of it larger term, you can make it go faster. But here I noticed, so I'm like, okay. So days, the next breakdown would be hours. The next breakdown would be minutes. And then we make it to seconds. So we got our days. We want to make the days go bye-bye. How many hours are there in a day? 24. So goodbye days. All right, we're down to hours. We're rolling. Got that. How many minutes are there in an hour? 60. Hours. Out of there. We're down to minutes. How many seconds are there in a minute? 60 again. So all the labels, we have worked our way all the way down to seconds. Now it's just the multiplying game. Whew. When you think of it that way, days are kind of long.
On what you're doing, actually.
It is true. It is true.
If you spend a whole day on vacation, then they'll not be long at all.
No, absolutely not. So here's what I want you to try. Go down to number 4. Inches to yards. Give that a shot. Everything you could need, I believe, is going to get in the chart. Those of you checking this out later, freeze me for a moment here. We'll see. Will warn you, you are going to get a decimal for an answer. So if you get a decimal, don't think something went bad. You are all good. Couple more moments here to make sure we're good. A couple things left here, then we'll let you get your stuff done. And I will say one of the measurements is not on your chart, but I think you probably know it if you just take a moment. So if we're going inches to yards, now, if you knew right away that there were 36 inches in a yard, you could do it in one step. But if not, you can go from inches to feet, which is what I did here. There's 12 inches in a foot. Get rid of my inches, down to feet. And then from your chart or your own knowledge, there are 30. Oh, I could have gone just to 36 inches. Oh, man. I made more work out of this than I needed to. Oh well, that's all right. So if you did the 1 to 36, you were actually quicker than I was. It happens. It does. Even Hardy's slow sometimes, just saying. All right, let's see. Yeah, let's do something that's not normal here. Jared can work 54 math problems in an hour. How many problems can he work in 10 minutes? That's like, okay. So we can do 54 problems in 1 hour. We're not trying to change the problems. I don't know how we'd cancel that anyway. But we're trying to get the hours down to minutes. So, how do we dump the hours? How many minutes would there be in an hour? 60. Okay, so we're rid of the hours. Now, here's where I got to be careful. Every other one, we would just go from here. We're like, okay, we got problems in minutes, we're good, but we want to know how many you can do in 10 minutes, not per minute. So here, there's one extra piece, because this is how many problems. We're not looking for minutes. So in 10 minutes, now when I multiply, the only thing left is problems. And that's what we're trying to figure out here. So let's see here. 54 times 10. And then we're dividing by 60. So we got 540 problems divided by 60. Looks like Jared can do about 9 problems every 10 minutes. So that one, a little different as well. And just to make sure we're good on it. Oh, here's this again. All right, one last time with this. Here comes the cubic stuff one more time. So I look at this and I'm like, all right, if a pitcher will hold 2 cubic feet of lemonade, man, that's a big pitcher. That's a big pitcher. How many cubic inches of lemonade will it hold? Okay. So 2 cubic feet. We're trying to work feet back down into inches, and then we'll worry about the cubed part. So how many inches are there in a foot?
12.
12.
So it's 24.2 feet.
Ooh. Now here, but that only takes care of 1 foot. You're like, oh, it's this again, like that other one we did on the front. If there's 3, if it's feet cubed, we're going to have to do this 3 times. Because sort of like when we were doing the centimeters and meters before, we've got to make sure that we have enough feet, 1, 2, 3, to cancel the cubed. Unless you want to figure out what 12 cubed is right away. So here, everything went away in the denominator. We just got a lot of multiplying to do up top. Make sure my multiplying's going right here.
But you do 2 times 12 to the 3rd power.
You could, let's see, 2 times 12 to the 3rd power. We can do it that way too. Faster your way, definitely faster your way. And making sure we get that set. So, okay, not bad, not bad. So, here's what I'd like you to try. So we're going to be, hey, look, I think I've seen this somewhere before. So the practice on page 19, just 19, we don't have to go crazy here day 1 of this, is doing the conversions on this page. I'll tell you in advance in case some of you are like, really? No, then if you want to work ahead, tomorrow we're going to be playing with like 20 to 23 because there's like a puzzle / picture that goes with it again. Because this is something that does have quite a bit of use as you go. So just 19 today. We'll play with those other ones tomorrow, and then we'll change over to percentage stuff coming to end the week.